So D8, 55, again, we'd swap the bits, and that would be 55 D8. When you convert that to a decimal, that comes up to 21,976. However, what SQL Server does is it retrieves March 3rd, 1960. The reason it does this is SQL Server, when it deals with date time, it takes into account the number of days since January 1st, 1900. So 21,976 days after January 1st, 1900 brings us up to March 3rd, 1960. A little convoluted, but it works for Microsoft, so be it. And so that's why it's important to understand the differences in the way data types are stored and retrieved by SQL Server, especially when you're looking at the hexadecimal. You need to understand what was stored and what was retrieved. The procedure cache contains ad hoc and parameterized statements. So before SQL Server will execute work, it definitely wants to make sure it has a plan to make sure it can perform the statement in an efficient manner. So if you issue a statement against a SQL Server, selects column 1, 2, and 3 from table A, SQL Server will take a minute and say, what's the best way for me to execute this statement? Are there indexes I can tap into? Should I just do a table scan? So it goes through a lot of compilations and work in the back end, and what it does is it puts together an execution plan. This execution plan is kept in conjunction with the actual text that was executed by the SPID. And this is stored within the procedure cache. And by tapping into this procedure cache, we can actually determine after the fact what statements were executed within the SQL Server. Parameterized statements are just like the ad hoc statements. Something I don't think I clarified was ad hoc statements account for selects, inserts, updates, and deletes. Parameterized statements as well account for inserts, selects, updates, and deletes. However, what SQL Server does with parameterized statements is any literal values SQL Server finds it will replace with an actual variable. And it replaces that with a variable in order to reuse the plan multiple times in order to save time in execution. Next, database evidence repositories. SQL Server data resides natively within SQL Server and stored externally within Windows. Those of you who have worked with SQL Server know that SQL Server is heavily intertwined with the actual native operating system of Windows. Some of the evidence repositories that you can tap into for database forensic investigations, we're going to focus on the ones in red. However, I'll talk briefly about all of the repositories today. So volatile database data. These are the sessions, the connections, the logged on users, the running processes that are active within SQL Server. All these contain evidence and database information that can help in a forensic investigation. The database data files we discussed, the log files we discussed, the plan cache we tapped into as well. The data cache, SQL Server does not allow direct access to any index pages or data pages. So what SQL Server will do is it will read index and data pages into memory. This area of memory is called a data cache, and any statements that are executed against SQL Server tap into this data cache. Indexes we just talked about briefly. B-tree indexes are used by NTFS within Windows to help organize files and directories. SQL Server, if it's not broke, it doesn't fix it. SQL Server does the exact same thing for its internal indexes. And the same benefits you get from traditional forensics and tapping into the NTFS B-tree indexes are the same benefits you can get within SQL Server. Excuse me. Next, the version store. SQL Server 2005 introduced a version store. What the version store is depending on the isolation level you have your SQL Server configured to use. SQL Server will record previous versions of data rows. So this, again, is another repository that we can figure out the history of data prior to modifications. Within the operating system, trace files, SQL Server has a default trace file. It runs by default. As soon as you start your SQL Server instance, it records authentication information, DDL operations, etc. System event logs, that goes without saying. It records authentication information, server startup, restarts, etc. The SQL Server error logs as well contain the same information. Is that a question? Nope. Okay. Stretching. I got you. No problem. The page file, again, is memory contents, and that's page from memory to the disk, and of course the actual memory in use within the operating system also contains SQL Server data. Some of the investigation tools we can use when conducting a forensic investigation. I've listed a few here. SQL Server Management Studio Express. What this is this is a free GUI that's released by Microsoft, and this allows you to attach database files, log files, and manage a database server or database files. It's the same interface you would find with the retail SQL Server Management Studio, except it's free and it's a little more lightweight. It's definitely instrumental, as we're going to cover later in the presentation when we're looking at the raw data files. SQL CMD, what that is, it's a command line query tool. Those of you who might have worked with SQL Server in the past, SQL Server 7, 2000, might have used ISQL, OSQL. SQL CMD is the next release that has replaced those tools. And what SQL CMD allows you to do is to issue TSQL statements against a Microsoft SQL Server. SQL CMD will log the statements you send to the SQL Server in addition to the results that it sends you back. You can record those logs in various log files, and you can MD5 sum them as well to make sure that they don't change. So that's an excellent tool, and that's freely available from Microsoft as well. Windows Forensic Tool Chest, I'm sure most of you or a lot of you today have used that in the past. It's a collection of Windows utilities that automate forensics, the acquisition of volatile and non-volatile data within the actual operating system. This tool chest can be customized in conjunction with an OSQL, ISQL, or SQL CMD to also gather volatile and non-volatile SQL Server data. And the next slide, actually, I have a demo of that. DD, DCFL, DD. Again, a lot of you today have probably used these tools before, and these tools allow you to acquire actual disk files off the disk and acquire that, whether it's to a network or to another location, and generate MD5 sums of those files. MD5 sum, again, is used in conjunction with the DD or the DCFL DD utilities. Netcat, CryptCat, depending how you're getting those data files and the files you need to acquire off that disk, you may want to send them over the network and use CryptCat or Netcat, so these can definitely be helpful when getting evidence off the database server. WinHex, we're going to talk about this briefly later in the presentation, but when you need to look at the actual transaction log, WinHex is a great hexadecimal editor that you can see the innards of the transaction log. And native SQL Server views, functions, and statements. There's a large amount of views, functions, and statements that are freely available from Microsoft that we're going to tap into in the next upcoming slides that will gather internal SQL Server information and data that's not readily known today. And it's not really a tool, but I decided to include it here. Lots of sanitized acquisition media because databases are extremely large. I cover a few techniques on how to reduce large data sets, but no matter which way you slice it, you're going to need a decent amount of media to acquire some database or transaction log files. So now that we're done the forensics primer, we can focus on evidence collection, which is how to acquire the actual SQL Server database forensic information. Just like a standard traditional forensic investigation, you want to make sure you determine the scope of evidence collection. If you're investigating a case that the span of events is the last week, you don't want to acquire the last 7 years of data. It's just common sense. The more information you gather, the more information you have to go through, so make sure you keep it tight and you acquire only the information you need to. Just like traditional forensics, database forensics, you're going to need to prioritize your evidence collection. Things will change slightly depending on the scenario you're investigating. A rule of thumb, though, I've listed in order here. Volatile database data, so again, your sessions, your connections, active requests, users, etc. Your transaction logs. Your transaction logs are critical in investigating databases, so that's absolutely something you're going to want to acquire extremely early in the acquisition process. Database files, SQL Server error logs, system event logs, and trace files, again, are also items you're going to want to gather extremely early in the process. Next, collecting volatile database data. So we talked briefly a few slides back on Windows Forensic Tool Chest and how it can be used to automate not only operating system volatile data, but as well how it can gather some of the SQL Server data. And the benefits of WFT is it gives you a GUI front end. It validates the binaries you're using. So if you're using in conjunction with SQL CMD, it validates the signature of SQL CMD, in addition to hashing the output files you get. So it's a one-stop shop with very minimal customization. Based on the screen we're looking at here, I'm not sure if you can make it up from your Vantage area, but we just have a command that dumped the users from the SQL Server database. It validated the SQL CMD signature, and it hashed the output files. All the database commands that we've automated can be placed as well in the navigation menu on the left of Windows Forensic Tool Chest. So within the area on the slide, I have a list of databases, the connections and sessions that are active within the SQL Server, all the active logins, and any requests that are executing as well. So you can, again, you can customize and you can tailor this depending on the investigation and the different types of evidence that you want to view and obtain. So once you finish running WFT to acquire that information, of course, you're going to want to execute ad hoc statements against the SQL Server. So SQL CMD, again, highly recommended tool of what you should run. Not sure if you can make out the output, but what we're doing here is just executing SQL CMD, connecting to a database server, and just recording information, and we're specifying what delimiter we want to use for the output file. Collecting the active transaction log. Don't just jump right in and try and acquire the transaction log. It's an extremely critical source of evidence, and we're going to want to make sure that we actually do it right. So there's a few steps we have to perform to make sure that we do acquire the active transaction log and all the correct elements. So the first thing that you should do is figure out transaction logs. Any SQL Server database can have multiple transaction logs. We need to figure out exactly where the transaction logs reside on the system. sbhelpdb in the name of the database. If you execute that command, it will dump all the data files that are associated with a given database. So within the results here, we can see that the MDF file, which is a data file we discussed earlier, is located in the default directory. The log file with the LDF extension is located in the default directory, but as well there's an additional log file in a non-default directory. So it's a good example that data files can be contained anywhere on the operating system and to understand where they're located prior to acquiring the evidence. Once we know where the physical log files are, again, we discussed every LDF has multiple virtual log files. To understand the status of these virtual log files, we can run the command dbcc loginfo. What this does is it just dumps all the virtual log files that exist within the LDF file and what the status of these virtual log files are. Based on the screen capture of the results we have down here, on the file ID 2, which is the